Okay, in the tic-tac-toe example, we use 1 for X and -1 for player O. Explain how to modify the program's counting trick to decide the winner if we use 1 for player X and 4 for player O instead. Can we use any combination of values for A and B? Yes, because you could make this into a template and use generics and stuff like that. I think it was in one of the examples in 2, in object-oriented design, I think. There was one where it's like you only make it templates. Yeah, you could use class templates or function templates. And then that'll work. I don't feel like doing that. Give C++ code for adding E and removing I functions for game entries in an array A and in class scores in section 3.11, except this time don't maintain the game entries in order. Assume that we still need to keep n entries stored in indexes 0 to n-1. Try to implement the add and remove without using any loops, so that the number of steps that they perform does not depend on n. I mean, you can. So they want us to make it not in order. We still need to keep it between 0 and n-1, but try to implement the add without using any loops. So don't make them maintain in order. Well, that's easy. You just delete code. Okay, so here's game entry. Constructor name, get score. Okay. Scores, add, remove, game entries. Okay. So let's just go to add and remove for game entry, I think. No, it wasn't. It was scores, source, scores. Did I have an add? I had to have an add though, right? Oh, this wasn't implemented. Oh my gosh. Okay, so I have to do that. Let me go get the add function in game entries, and then I will do that. First, let me just find it. I think it's over here. So they had an add. Okay, right here. Scores, add. Let's copy this. Where's scores? Where's add? Scores. Right here. And then we'll just paste it here and then save it. Oh, nope. Unicode, -1, -2, -. Okay, this is entries. Okay, so let's see. They want us to do add and remove except not maintain it in order. I mean, you could do this. You just have to have a position in the last where you're currently at. So let's see, if what were they saying here? Let's see, what do they say? If not full, add one more entry. So so add a game entry. This is a score to add. If the array is full, there's not enough entries, return, yeah. If not, the number of entries ++. Start with the last. Shift right if it's smaller. Okay, then put it in. So if you just don't want it to be, if you don't want it to be in order, you would just do game entry at entries +1 and then do it, if that makes any sense. It would just be entries at num entries equals to whatever your new entry is. Right, yeah, okay, so they want us to not maintain an order. So I'll just comment this out. So they had num entries equal to max entries. So right now num entries start with 0. Let me see. Okay, so num entry starts with 0. So if it's not greater, okay, so I'll just comment this out. Because this is the part where it's sorting it, right? because they want us to not maintain an order. So we're basically just going to put this in here. What was it? Entries at the number of entries plus plus is going to equal to E, new score, E, I think, yeah, E. That's it. That's all you have to do. I'm pretty sure this would work, assuming that we're still in order, like excuse me, we're still in between 0 and n minus 1, between 0 and length. That's what we're doing. So let's just go back to source and let's create a let me take this out. I need to include game entry, I think. No, it was source scores. Include scores, I think. Where is it? Where was the header for it? Game entry. Okay, so scores. I need to include scores, so I need to do scores.h. Hashtag include scores.h. Okay, so I have that, and now I just have to create a score. My scores. Just delete this. So I create a scores, and then now I just have to pretty much where is it? Where's scores? Where's scores? Let me see the constructor. Okay, give it max entry, so I'm gonna give it 10. I don't know, 10 probably. Okay, so that gave it 10. Now I need to I'm gonna add, and then I'm gonna display them all. So wait, if I want to display them, I have to overload the I need to overload the I don't think I could display it in main. Let's see. I have to get every single entry in game entry, which is in scores, I think. So I have to loop through for loop for I equals 0, I is less than max entry is 10, and then I just display entries, see out entries at I. And what is entries at I? Entries is a game entry, so I have to go through game entry, and game entry I should display this name and this score. Yeah, okay, so in scores I need to add game entry. So wow, okay, so this is gonna okay, so just to test this out, I need to overload the operator overloading to overload the less and less than, because I want to display the game entries for game entry. Because if I want to print out scores, I have to see out I want to print out all the scores to make sure it's the right one. I have to pretty much overload the less and less than operator. So to do that, I'm gonna have to first overload every single game entries. So I have to create a method here that overloads it. Let me just quickly search up how to do that, because I completely forgot. Overloading operators in C++. This is that one thing that I always forget. Like this is very important, because if you want to print your object, you have to overload it. So I think it was less than equal, less and less than operator less and less than. No, but I need an off stream, right? Yeah, so I need to create a friend off stream. Where's this? So I need an off stream and then output, and then the current object I'm overloading. Okay, so okay, so where did they do it? off stream, off stream, off stream, off stream, off stream. I think it was this one. No, not this one. This one. No, not this one. This one. No, this one. No, this one. Yeah, it was this one. Okay, so I'm not gonna copy it because I need to remember how to write it out. So it's off O stream. Reference operator. O stream. Out. Const. Game entry. Game entry, and then we're using reference my game entry. What's the matter with this? Okay, so now I have this. So I need to make this a friend function because now I have this. I'm going to go to my CPP file, which in game entry, which is over here. And then I need to do, not this, this is accessor, this is the game entry. Is it like this? I don't remember. Is this how you do it? No member O stream. Let me see. How do they do it? Let me see. Oh, I need to do IO stream and include that. Oh, it's not. Oh, it's not part of the counter class. You don't have to put counter. Okay. Please tell me in the comment section below why you don't need to do that. Like, I don't need to put a game entry for some reason. Technically, I don't even need to put IO stream technically, but it doesn't matter. Okay, so I'm gonna do out, and I'm gonna print out every single my game entry, and because it's passed by reference, I'm gonna do dot get name, and then my game entry get score, and then I'm do endo. So that's what they did here, right? Yeah. No. You have to return out. Damn. Okay. Return out. Okay. So that's that. Or did they have an output? See out. So can I make it like a string? Because I wanted to say name, and then I want to do space score. I think so. Name score. So it's space score. Okay, so then I return that. That's the game entry. Now I have to do the same thing for score. So in scores, however, difference is that when you do off stream, when you overload the operator, stream, I have to be a friend. So access is variables. What is it? Ampersand operator. I forgot already. Wow, that's pretty sad. Okay, where is it? Why can't I do this? Why is max entries not there? It's scores. It's in scores. You have max entry. Oh wait, it's because okay, I didn't finish writing. Okay, where is game entry? Give me this. I'm taking this. Scores. What was it? Let me paste this here. O stream and operator. O stream out. So I need to take this. O stream out. O stream out, right? Okay, so I have O stream out. Okay, so I need to make this a score. Score log. Current score, my score, or whatever. Current scores. Current scores. Okay, that makes more sense. Okay, so I have that. Okay. I have that. Now I need to put this into the thing with the thing. Score, source file. Not source. Scores. Right here. Right here. Right here. So I overloaded this. I don't need the friend anymore because I don't know why you don't need the friend anymore. Output cur scores. Fudge cakes. For loop, because scores is every score has a game entry. So if I'm printing the scores, I need to loop through every single score, game entry and scores, and print them out. So how do I do that? I need to do a for loop int I equals 0, I is less than nums entries, I think is a number, I don't know, something like that. It was something here. This. Why don't I have access to this? Okay, fine. If I can't have access to this, I have a getter for get, num entries. Okay, so I'm gonna loop through this and get every single num entry, and then I have to display it. So I have to do out. So I'm gonna do out. So first I'm gonna do all scores. Right, and L. And then I'm gonna print out current scores entries. Is it entries? Yeah, entries at I. And then for every entry. Did I have an end L? I don't think I did. So wait, let me see. Did I have an end L for every single entry for a score? No, not this one. The game entry. Yeah, I did. So I'm going to get print name as score, and then for the scores, the game entry, this game. Game entries. Current score for current score. I'm not gonna put an end L because I'm guessing when you call this out, this is going to call the overload operator for that, for the other one. So whenever I print out every score. So that's going to do that. Then I'm going to be output, I'm going to do this. Okay, just for funsies, okay. Okay. So, yeah, and then I'm going to return out. So now I have that. So I could print out all the scores. I need to, there was something wrong with remove when I checked the scores. Oh yeah, here. Okay, I didn't copy the remove, which is sad. Copy this. I'm gonna copy this. So I'm copying this over. Okay, and now I have this for the remove for in scores. So I have scores, and then I'm gonna do copy this over. So this is remove. Save it. Nope, something's wrong. Okay, index out of bounds. I don't have that. I don't have that exception. I'm not throwing it. I'm not gonna do this. I'm gonna just print out invalid index. See out. Invalid index. Okay, something's wrong. This has to be -1. And this has to be minus. Okay, yeah. So now I have that. And did I return out? Okay, so now let's test it. So I create a maximum score of 10. Let me see the constructor for scores. I'm gonna add scores. Add. So I have to create. Do I have to create every single score? So I need okay, so I need to create every single game object and game entry. So do I have a game entry? So I'm basically going to do .add game entry. Okay, so I'm gonna do for int I is less than 10, I plus plus, for int I, I'm gonna add every single game entry. So I'm gonna do my scores .add. So I need to create a new game entry. So I'm gonna do game entry new to add. This is gonna be have a name of. Well, I don't want to do. I have to do this individually because. Yeah, I have to add this individually because I need to do this like this. So add let's say John, and then what was the other one? Game entry, game entry, game entry, game entry, game entry, game entry. Score. Let's say 10. 10. John, 10. Why is it not letting me do this? Type name is not allowed. Why? So just like that. That's very strange. That is so strange. Okay, game entry. Bob. Game entry. Dylan. See, he got a 90. Okay. Let's say game entry. Susan, let's say she got 30. Game entry. I have to do this 10 times. Okay, let's just do it 5. 1, 2, 3, 4, 5. Okay. Let's do 4. 1, 2, 3, 4. Now I'm gonna print out my scores. Because I overloaded the off stream, I should be able to print this out. Come on. What are the build errors? Standard syntax. What is this problem? Get name. Is it a method call? Right? Why didn't it make it a method call? Okay. Whoa, whoa, whoa. Hold up. So it printed out all scores. Name John, scores 10. Name Bob, score 11. Name Dylan, score 90. Name Susan, score 30. Okay, so it did that. So that worked. Let's see if I comment out the... If I just comment this out and have the original one, would it still... It would do it alphabetically, right? It would do it alphabetically for every score. So let's just go back to see if it's doing it alphabetically. If I just take out the else and add else num entries plus plus. So instead of doing this, I'm going to do num entries plus plus. And then now I'm going to do this. And this ideally should add it to the right. This is going to make it alphabetically order. By, yeah. Wait, so it's doing shift right. Start with next to last. So this is going to put, did this actually do it right? Okay, so it did, it sorted it by highest score to lowest score. Okay. Woo, that was pretty good. Wow, that was a tough one right there. Okay, so we did that. The same thing is the same for remove. So for remove, You basically just set it to an empty entry. So, instead of shifting it left, you just do num entries minus minus. Or you can set it to null. At num entries minus minus equal to null. I think that would work. Yeah, I'm not gonna code that. It's way too much time. Okay, so let's go to the next one. Let A be an array of size n greater than or equal to 2, contain integers from 1 to n minus 1, including with exactly one repeat. Describe a fast element for finding the integer A that is repeated. Okay, so how are we gonna find the integer A that is repeated? What I'm thinking about is the only way to do this is to have 2 for loops, loop through every single one, checking the next one to see if it's repeated or not. But I don't think that's the right way. Let A be an array of n is greater than or equal to 2, contain integers from 1 to n minus 1, including one with exactly one repeated. Describe a fast algorithm for finding an integer A that is repeated. I don't know. I'm thinking you have to use 2 for loops, like one starting from the first. So I'm thinking of is that in order to find the one that's repeated, you have to have 2 for loops looping from so let's say I have an array A that has 10 integers, and then the number 1's repeated. Let's say 1, 2, 3, 4, 5, 6, 7. Okay, let's say 7 integers. So I'm thinking in order to do it, you have to loop through from 0 to 7, and then loop through from the next one afterwards. So if I start from 1, I have to check every single one to the end. Then I have to start from 2 and check everything 1 to the end. But there might be a better way to do it. Here, I'll just show you what I think. This is what I think you have to do. And you say if A at I is equal to A at J, then the number A at I is repeated. So that's what I do here. Okay, so here we have, yeah, so the number 1 is repeated. See, that's the thing. That's what I think in order to do. But I don't know how fast way to do this. It might be that thing with the pair. There was one thing I remember in the Recursion chapter about having an extra pair. Guys, tell me the fastest way to check it for repeating numbers, because I don't know. Okay, C is the same thing. Okay, let me think. There has to be a way to do this, checking for repeated numbers. Stop. I said stop. Because remember, I think it was linear recursion. There's one where they do the factorial run. Tail recursion, right? Then they didn't want to do binary recursion, so they did something where they made the pair. Yeah. So they did a pair of this, and they if it's less than or equal to 1, they return k at 0. Otherwise, they return k pair at I plus j in I. What if you create a pair? No, I don't know. I don't know how you would do it. I can't think of a fastest way to do it. And 3.3 and 3.4 are the same. Finding the if 5 integers in B that are repeated. This one's just finding the one integer that's repeated. So how would you find if they're repeated? Fastest way to do it. I only could think. What I thought of was just using 2 nested for loops. But there has to be a way to do it one. Alright, put in the comment section below if you could figure it out, because I can't figure it out. Having one nested for loop. Okay, if you could do it in one nested for loop. Okay. Suppose you are designing a multiplayer game that has over 1,000 players, and it's going 1 to n, which enchanted for. The winner of this game is the first player who can meet all the other players at least one. Ties are allowed, assuming there is a function called meet, which is called each time a player meets a player I not equal to j. Describe a way to keep track of the pairs of meeting players and who is the winner. These are so hard. This is the same thing as 3.3. Okay, let me see if I could find one. How to fastest way to find a pair in C++. Okay, the reason I'm sorting pairs of vectors because I want to. Okay, so you do not need to use. Don't need to just find. I don't know. Okay, fastest way to C++ fastest way to find repeated number in array. Yeah, this is what I was doing. It has to be a more elegant way. You could sort it in n log n and then simply look at until the next number. That is substantially faster than your n square. The code is also a lot cleaner. Your code doesn't assume no duplicates were inserted when they were re-entered. You need to prevent duplicates from existing in the first place. Okay, so all they say is just sort it. You could sort it and then check and simply look until the next number. Oh man, I'm stuck on these two. Assuming there's a function called meet, which is called every time a player meets with I and j. Describe a way to keep track, fast way to keep track of the pairs of meeting players and who is the winner. That's super duper hard. Okay, let me check if let me search this up. I don't think there would be anyone. Oh my gosh, there's no experts answers. I don't know. This is really difficult. Well, this is the same question that I have. Let me see here. Is there an answer key? I'm not even sure. Well, put in the comment section below the fastest way to do this. I don't know how to do this. Give a recursive algorithm to compute the product of two integers using only addition and subtraction. Okay, that's not that bad. Yeah, that's not that bad. Here, I'll do that right now. Okay, so I'm going to have a product of two Okay, so number one. First number and then second number. So I'm gonna have to keep calling this. I have to keep calling this until first, decrementing the value of first, and then the second I have to, let's think about this. If I want to do 2 times 3, how do I do it? Well, 2 times 3 is essentially 2 plus 2 plus 2, 3 times. So how do I do that? I basically have to keep calling product 2 plus 2, but I have to add 3. Three times. See, that's the problem. You don't know how many times you're adding it. Yeah, you do. It's second. So, okay, so you pass in second. Okay, so I basically have to use a for loop. Keep adding this to the, okay. Number returned 0. Number returned is gonna keep plus. I'm gonna keep adding this, and I'm gonna return. So this is basically saying, okay, so I'm gonna keep adding the product of this and that, but I need one thing. I need the recursive call to end. So basically I have to if product of 2, if second is equal to 0, yeah, okay, so I have to do second minus 1. If first is equal to 0, wait, no, if first is equal to 0, no, you're not decrementing first, you're decrementing second. So if first is equal to 0, if first is equal to, no, if second is equal to 0, then we're going to return first. If second is equal to 0, we return first. So then it's going to do num plus first. And then it's going to keep calling this again. I think this is the best way to do it. I don't know. I don't even know if this would work, actually. So let's just copy this. Put it here. Let me just... cut this. Put it in here. Let me just copy this. Product of 2. 3 times 2. Fine. 2 times 3. This should return 6. Okay, 3 times 2, this should return 6. If there's a problem, this returned 12. Okay. Let's just see what's the problem. Let's see what is the problem. See what is the problem when you could just return 12? I mean, let's okay, 11. Second's not 0 to return. We're gonna keep adding. Second's not 0. We're gonna keep adding. Keep adding. First. So add first. You're supposed to add first some amount of seconds. So this number return is 2. Return 2. Number return is 2. Okay, number return is 4. Number return is 6. Wait, is it going to return 6? Four again. 8? What? What is going on? Okay, maybe you don't need the for loop. You might not need the for loop. What if I just add like that? Now it should work. Please tell me it works. And that just returns 2. So you need the for loop. Yeah. Okay, so I want to return 6. So I need to keep adding it until it reaches I don't understand why 2 times 3 is equal to 12. I don't understand it. Okay, you know what I'm going to do? So if equals to 0, return first, right? Return 1. Otherwise, 2 times 3. I'm not thinking of this through. Okay, so what is 2 times 3 is 2 plus 2 plus 2 3 times. So how do I do that? I need to add 2 3 times. But what is 2? Is it 1 plus 1 3 times? No, it's not. It's not. What am I doing? Okay, let me think. Think. So so I pass in 2 and 3, right? If 3 is equal to 0, return first. Return 2. So that should return 2. 0 plus 2, 2. That's not what I do. I want to keep calling this until I return. I want to keep adding this. So I said for loop. For loop int I equals to second 0. I is less than second. I plus plus. So I did that. Let me just see what's going on. Okay, so if I start with 2, second is equal. Okay, so first is 2, second is 3. This is first. F, this is second. Okay. Second's not 0. Okay, so 3 is not 0. I pass in 2 3, right? I'm gonna start from 0. I'm gonna sum up the loop from 0 to 3, and I'm going to add up the first 2. Yeah. So I'm gonna add up. I call second minus 1. So now 2 times 2. I'm gonna sum up. So what's 2 times 2? Well, 2 times 2 is that doesn't make sense. Two times 3 is basically add up to 3 times. So basically I have to sum up 2 numbers. I need to keep summing. What am I doing? Oh, this is really hard. Alright, guys, so I think I know how to do this. Okay, so 3 times 2. 2 times 3, what is that? That's 2 times 2 plus 2 times 1. That's what it is. Okay? It took me so long to figure this out. Okay. And what's 2 times 1? 2 times 1 is 2. Can you believe that? Okay, 2 times 1 is 2. Oh my god. Okay, so What's 2 times 2? 2 times 2 is 2 times 1 plus 2 times 1 plus 2 times 1. Oh my god. That's mind blown. Okay, so I could code that. I could code that. I think I could do that. Okay, so we don't even need a for loop. This is what we need. So what is 2 times... Okay, so what is 2 times 3? Well, 2 times 3 is 2 times 2 plus 2 times 1. So that's product of 2 times 2, which is first, second, minus 1, plus first, second, minus 2. Of 2, first, second, minus 2. And that's what it is, plus those two. And then what do? I'm going to return this. I'm going to keep returning this. And what does that mean? Well, it means that if second is equal to 1, then I return first. If second is equal to 1, return first. Okay, that's what it means. So if I 3 times 3 minus 2 is 1, right? So what if I do 2 times 5? Well, okay, let's just see if this works. I hope this works. Okay, so I was thinking that this would work, but I don't know. Pray. Should be 6. Okay, I have an exception handling. Stack Overflow. Okay, the Stack Overflow error happens because... Oh, it has to be less than or equal to 1. Let's try it now. Okay. 6, yes. Okay, so we got that. Okay. So what if I do 2 times 100? Should give me 200. $200. Do I have a Stack Overflow? That should give me a Stack Overflow. I'm guessing it's just really slow because it's recursive call. What if I do 2 times 20? Should give me 40. No. That's not right. Why isn't that right? Think. Why isn't this right? 2 times 2 times 2. 2 plus 2 plus 2 plus 2. It should be 40. Why isn't this right? I don't understand why. Okay, let me try it again. But I thought I got it right. I actually thought it would be. What if it is equal to 1 and second is equal to 0? I actually thought I got this right. I still have a Stack Overflow. Why? Okay, less than or equal to 0. Think about, okay, why isn't this working? Okay. What if I do 2 and then 2, 5? 2, 5 should give me 10. Just give me 10. Give me 16. Why? I'm curious. Why? Think about it. 2 times 2. Okay. 2 times 2. No. 2 times 5 is equal to 2 times 4 plus 2 times 3. No, it isn't. 10 is not equal to 8 plus 6. Okay. 2 times 5 is equal to 2. In terms of 2s, it's okay. 2 times 5 is 2 plus 2 plus 2 plus 2 plus 2 5 times. 1, 2, 3, 4, 5. Okay, let's think about this, how to do this iteratively. So how do you normally do it iteratively? Well, in iteratively, you just loop you have a sum equals 0, and you loop through from to the second, and you add sum equal to first, and then you return sum. That's how you want to do it iteratively. Okay, This is how you would do it iteratively. This should ideally give me 10. Yes. So now, how do you do it recursively? Well, I need a recursive call that keeps adding until I get to something. So I have to call product of 2 every time. So if second is equal to 0, if second is equal to 0, I return first. Otherwise, I'm going to basically return first plus product of 2. Second minus 1. This should work. I believe it does. Has to work. It will work. It's going to work. 12. Why is it 12? Why does 2 times 5 equal to 12? I'm curious. Why? Why? 2 times 5 should not equal to 12. Okay, we're debugging now. We're debugging. Okay. We are debugging. Okay, so this should return 2 plus 2, 4. What's 2, 4? 2, 4 is 2 plus 2, 3. What's 2, 3? 2 plus 2, 2. What's 2, 2? 2 plus 2, 1. What's 2, 1? 2 plus 2, 0. What's 2, 0? 2 plus... Oh. 2, 4, 6, 10, 12. Oh. Okay, so I got it, guys. It's when second equal to 1. Now this should work. Ten. 2 times 5 is 10. Oh my god. Okay, it worked. Okay, what about 2 times 10? Should be 20. 20, yes. What if it's 100? That's 100 stacks on the frame. It doesn't matter. It doesn't matter. We're doing this because we're trying to get 200. Yes. Oh my god, I never felt so happy in my life. Alright guys, so now we're going to reverse a singly linked list. So the order becomes opposite of what it was before. Okay, so I need to copy the code for a singly linked list because it's not the same code as the other one. Where is it? Okay, so add front. Where's the code? Okay, so S node, single linked list. Okay, and that's all of it. Okay, so I'm going to copy it. So this is a singly linked list. So where do I go? Okay, I'm going to get my Visual Studio up. Let's just see what I'm capable of. Okay, so I need to create a new class called SNode. Then I need to create a new class called singly linked list, I think. So I already have circular linked list, but single linked list and circular linked lists are different. So SNode is a class, and I'll just create that quickly. And this is the header file, I think. No, is this the header file? SNode. Yes, okay, so this is the header file. Now I need to copy this, SNode. Type name is the generic, so do this. Okay, no errors. Okay, so now SNode CPP. Whoops, my bad. Whoops. Okay, so SNode CPP file. singly linked list. Okay, so this is singly linked list. Where's S node? Where is the S node? Oh, they never have constructors. Why don't they ever do that? It's so stupid. Okay, now I need to create one for the class of S singly linked list, S linked list. So I have to create that class. Okay, so I do that, and yeah, boom. Okay, so now I have that. So now I have to create the singly linked list class. So in order to do that, I have to make a copy of this. Do that. Where's the linked list? Okay, so now I have that, but I need to add the implementations, which is all of this. So I have that. Is that everything? Sounds kind of strange how that's. Okay. Need to do. Did I just delete the header file? Wait, hold up. Yeah, I just did. Okay, so delete this. Do that. Save. Something wrong with Unicode. Where? Oh, this one. Unicode. Tilde has to be that. Tilde. Anymore. Okay, so saved all the Unicode. Okay, so get the constructor, get the template. The template works. Okay, that. Okay, that works. What is this? What's wrong with this? Okay, so that's also template. Okay, we have that. Okay, so we're gonna remove singular linked list. So how do we do that? Okay, so I need a function called reverse. So I'm gonna go here and I'm gonna create a function. And why? They don't have a destructor? Oh my god. Okay, let me see something. Where's their destructor? Oh, they do. Wait. This is the destructor. Why is... This is the destructor. Oh my god. Okay, so I got that. Now I'm going to have a function called reverse. And what is this function going to do? It's going to return a new singular linked list, which is the type sing linked list. And it's going to be called reverse. And I am going to reverse everything here. Okay. And I need to add it into the file also. So here I'm going to have a template type name E. So it's going to be called sing S linked list. Yeah, S linked list E. It's going to be a new singular linked list called reverse, and I'm going to reverse the linked list. So how am I going to do that? So I'm going to basically, okay, so if I want to reverse it, I need to have a helper function. What is the helper function going to do? It's going to have it's going to basically have a node. It's going to return a node. Yeah. So where's my linked list? So my singular linked list head is normally instantiated to null, and then if the front is head's element, and then destructor, you keep removing it, right? So adding to front, they create a new node, then they set all the elements, and then they point head to it, right? Moving the front, they save the current head, they skip over the old head, and then they delete it, right? But now if I want to reverse, I'm going to have a singular linked list, and then what I'm going to do, I'm going to basically call it, N. No. Okay, so I have a new single linked list, and I'm basically going to keep calling this function single linked list. No. Okay, so what is singly linked list? Well, singly linked list is just a linked list that has a constructor, right? So it's a singly linked list that heads point to something. So whenever you add a new node, what do? They add. I'm trying to think how to do this. So they create a new node and then they store it, and then they said head point to that. Well, I'm going to have head point to a new linked list. Not linked list, a new node. So I'm basically going to have, okay, so it's not going to return a new one. It's going to return void. It's basically going to return, it's just going to reverse the whole linked list, the current linked list I'm at. Okay, that's what it's going to do. So where's my S node single linked list? So it's going to reverse. Okay, so what am I going to do? I need to create a private function that a private function is going to return head. Yeah. Okay, so I'm going to have a private function called reverse. This is going to return an S node. It's going to point it to a head S node called reverse. That's what it's going to do. Okay. This may look weird, but this is what the private auxiliary function is going to do. So here in circular linked list, I'm going to call the S node E, this reverse. This is basically linked list E. What the heck? What the heck? Oh. What the actual heck? Why isn't this letting me do it? It's part of the class. It's part of the class S linked list. Oh, okay, yeah. Okay, so I'm gonna call this reverse. And this reverse returns a pointer to the node. So here's the node. The reverse is gonna return a pointer to the head. So what I'm gonna do is in the reverse thing, I'm gonna call this function. Head is gonna point to this reverse list. Single linked list reverse. Okay. This keep in mind this is just the class's name. So I'm not going to this head points to this function that I'm returning, which I'm returning single node. Okay, so in single node, I am for the reverse. In reverse, I'm also taking a pointer to a current node. That's what I'm doing. Okay, so sorry guys, I'm taking a pointer to a current node. Okay, triple node. Where's singly linked? So I'm gonna take a current, and this is gonna be head. Passing this head, and that's going to set head point to that. I think. Yes. So basically what I'm doing is given a node, So let's say I have A, B, C, D. C. And I want it to be B, C, A, right? So what I'm doing is I'm basically having the head. This is the new function is going to reverse is going to have head point to the end. The head is now going to point to this function, and this function is going to return a node pointing to the head. So I'm going to, in my new function that I return, which is the reverse, it's C, B, A. So now this is C, A. So this is going to point to my new head. So basically in this function, what I did was a head point to reverse. New head is going to point to here, to the reverse one. So the reverse one, how do I reverse it? Well, given the current node, I'm going to keep calling reverse so I'm given this, so let's say I want to reverse, right? I'm basically going to set current node. So I have ABC, right? So I'm going to keep going right until I hit null first, right? Then until next is null, right? Then I'm going to, so once I'm at this end, I want to set this next is going to point to this instead. If that makes any sense. And I want to get this out. And then I want to set this to point to here. Okay, so I'm going to, so I have the node. It's going to return a node to the reverse list. So we're going to assume it's reversed. Right, so current next is going to point to the reverse list. So this is basically doing is saying, okay, my C is going to point to the reverse list. And I'm going to pass in current. Yes. Wait, no, I should pass in current. So then current's next is going to equal to the reverse list. Okay, so if current is equal to null, if current's next is equal to null, then I return current, right? So if I don't know if this makes any sense whatsoever. So okay, so I'm given the list of ABC. So I have ABC. A, B, C. I'm going to keep going right. Okay, so I have to actually keep going right. I don't know about this. Okay, I don't know if this works. Okay, so I'm going to keep going right. Okay, if my next is null, I'm going to return current. And then I said current's next is going to be equal to, wait a second. Okay, so I'm going to keep going right.